Now I'm going to introduce conditionals. In programming, there are many situations in which we need to ask a question, and based upon whether or not the answer to the question is true or false, do some particular thing. To do that, we use conditionals. But first, let's introduce a new variable type called a Boolean. So Python contains Booleans. Not all programming languages do, but Python does. And so a Boolean has either a value of true or false. And they do have to be spelled this way to mean something in Python. So in this code we see right here, I've created two Booleans. And when I print the results, or print what their values are, then we see they're true and false. So what are the conditionals we have available to us in Python? We have the if statement, the elif statement, and the else clause. An if can stand on its own. So I can say if some condition is true, do something. And then I can follow it up with one of these two if I want, but I don't need these to just use an if statement. These, however, always need to be preceded by a corresponding if. But we'll see that more in a moment. First, though, let me introduce more operators, and these are the relational operators. And the reason I'm introducing these now is because I would assume that in most cases, certainly not all, but in most cases when I'm using a conditional, it's going to involve some type of relational operator. Ultimately, each of these, though, needs to reduce to something that can be considered true or false. So let's see this in action. Just to demonstrate something from earlier. So if I say A is equal, notice if I don't spell it correctly, if I write true like that, it's still the same color. But if I write true, the color change indicating it's built into the language. And print A. There's also a function called bool that shows me the truthfulness of something. So both of these will be the same, actually. True and true. So let's do something like this. X is equal to 5. And then print bool is X equal 5. Before we move on, let me talk about that. When I write two equal signs, I'm testing for equality. So I'm asking the question, is X equal to 5? When I write a single equal sign like this, I'm performing an assignment. I'm giving X a value of 5. So this is how X gets the value of 5. This doesn't change the value of X. It's just asking the question, is it equal to 5? Let's do a couple others. Is it greater than, say, 99? Oops. Is X, say, less than or equal to 123? Let's check each of these. So these are still true. So yes, X is equal to 5. 5 is not greater than 99, so we get false. And then 5 is less than or equal to 123, so I get true. So we can see that these have truth values, which then we'll use in our conditionals here in a moment. But before I leave, let me point out, why do we care about Booleans? Well, there's times you want to have something where you just know it has a true or false value. So for example, I might have some type of flag situation, and without using a conditional, I can't really show it in use, but conceptually it might be something like this. I say, something's happened, and so now the status of that happening is true, because later I want to check and see if it ever happened. So I might have some kind of flag variable. Might want to see something like checked results equals true. And so then later I can test this to say, well, did I check the results? Well, yeah, it says it's true, so I know it happened. Things like that is how it would get used. So here's the syntax for an if statement, at least in the basic form. If is the keyword, then some condition that can be considered true, followed by a colon, and on the following line, what to do if it's true. And the indentation here is required. All right? Python requires that to represent what we call the body of the conditional. That is, those things that we can reach only if this condition is true. So assuming we had some variable X with a value that could be compared to a number 13, then I can ask the question, if X is greater than 13, if that's true, I'm going to print this right here. But if not, I'll just skip doing the print statement. Here I say, is y equal to 20? If the answer is yes, then I give a value of 66. Otherwise, I skip this line. Let's see a little bit more of these. We need something first to check. Equals 5. If x is greater than 3. Greater than 3. All right, we put that in there. Let's check this. We're print greater than 3. But I can do other things here. I could ask another question if I wanted to. If x is less than 99, less than 99. And so both those true. So how does this work? Well, to reach this line right here, I have to reach the body of this conditional. So x has to be greater than 33. If I do something like this, or excuse me, greater than 3. So if I put 1 in there, which is less than 99, but it's not greater than 3, we can see we don't print anything because I never get to this point. Because when this is false, I skip past it down to this level right here. Always get here. Right? So go back and change this to 5. And see, always get there. So I said you had to indent, but I didn't say how to indent. So you have two options here basically. Spaces, which is what I use, or tabs. Put a tab in there. It still worked. So what should you use? Well, my preference, and that's what it is a preference, not a requirement. My preference is use spaces. And let's see why. So now let's change this to 1. Let's test this before I make a change to point out something. Right? I'm going to change, both of these are using tabs, so that works. But now let me change this to spaces. 1, 2, 3, 4. And notice they're lined up here. So they look like they're at the same level. But when I run this code, Python says there's a problem. It doesn't know they're at the same level because I'm using two different ways to do the indentation. I can check this. If to my naked eye I see this right here, if you watched my video in which I give you a crash course on using Vim, the editor I use, as well as some of the Unix utilities at the command line, I introduce cat. So if I say cat ex.py, which is this file, we see they don't look the same here. But even if they had, then I could have done this and see that right there. So that says there's a tab there. That's how it's represented when I use cat-tv. And while we're here, let's point out these dollar signs at the end. That's where the new lines are at. Because in each of these cases, that's the last character on the line. If instead I do this and add some spaces, which aren't visible to the naked eye, they will show up from one of these parameters. See the spaces there? Because if I just type regular cat, I can't see their spaces there, right? So I prefer spaces because 1, I have more control over it, but 2, I never want to mix the two anyway. Although I could have this, if I have tab, that's also, let's put a tab in there. I could come down here and say, let's do this twice. Now I use 2 spaces just to make it clear they're not the same. See, it does work as long as I'm consistent within the same section. That is, these belong to this. So they're at the same level of indentation. They have to be indented the same way. All right. Another problem I have with tabs is that depending on your utility, you can indent them, or excuse me, you can have them represent different amounts of spacing. So notice when I ran cat, this one tab that's right here looks like 8 spaces. But over here in Vim, is defined to be 4 spaces, or at least that's what I have it set at, I think. It may also be the default, but I can't remember. But they're inconsistent. So here it looks like it's lined up, here it's not lined up. Maybe over here it's not lined up, but here it is lined up or whatever. It's just too hard to keep control of. So if I'm going to use spaces, how many do I use? Well, experience has taught me over the years to use 4. That's my preference. Once again, it's a preference. Now, I've known people to use 1. So let's do this. And put a bunch of blank lines in there. Are those the same? Well, yeah, they are, because you saw how I created it. But are those the same? When looking at the code, if I'm not specifically trying to see if these are at the same level of indentation, it's very easy to think they are. So I've found over the years when somebody only used 1, and with the if right here on at the edge of the window, it's easy to see it is indented. But when you start getting into other things like this, right, something like this, and especially if there's a lot of lines of other things going on between it, because I could do this. Let me just give you an actual example. Just check that before I show something else, so it does work. So I got there. How's that work? Well, this is at the same level as the conditional. So I can only reach this if this is true, but I reach it regardless of whether or not this is true. This print statement here is part of this conditional. This is part of this conditional. So when x is greater than 3 and less than 99, I'm going to print 1. Then I'm going to print x is less than 99. Then I'm going to print get here. If x is greater than 3 but not less than 99, like let's say 500, we got there. But then the problem gets into something like this. You know, you're looking at it here. What does this go along with? Well, it's actually part of this, but maybe what I really meant was for it to be this. See how they're difficult to see the difference between them? So I think that's too little. On the other hand, I've known people did things like this. And these would have to be at the same level. But they're way out here. Let's just get rid of this. Well, I think that's too much. It's too staggered. And depending on your window size and the size of the expressions, because these are small expressions, but I could have much longer expressions. Depending on what you have, then you end up getting with some situation like this. This is sort of bogus, but you get into a situation where ultimately things start wrapping around. If I have multiple levels of indentation and the expressions themselves are long, well, I don't like looking at this because now it's making me think it's part of this when it's really not part of that. So I've just settled on 4 over the years, but it is a preference, so you can do whatever you want as well. But I'd say make a decision that has benefits other than, you know, you just like the way it looks. It should be useful to you in terms of catching bugs and avoiding mistakes in general, right? So what if I need to do multiple things? Well, I just demonstrated that. I put them at the same level of indentation inside the block. So in order to give y a value of 10 and to print y is now 10, x has to be greater than or equal to 2. Both of these lines will be skipped if x is not greater than or equal to 2. I demonstrated this. We reach this line no matter what happens here. So here's a flow chart, that's what this is, for demonstrating how this works. So there's different symbols for different actions, but ultimately all you really need to care about is what this is saying is give a value of 5, then ask a question, is y equal to 6? If the answer is true, then I'm going to give a value of 10 and b a value of 23, and then continue on to print see, because it's at the level of ifs here. But if y is not equal to 6, Then I skip these two assignment statements and still come down here and print A. So for those conditionals I showed you with just an if, we saw that if the condition was true, we did something. But what about when it's false? Well, for those if statements, we don't do anything in particular if it's false. But there's lots of times when you treat it like a fork in the road, go left or go right, depending on your choice. So here I'm saying if this condition is true, do this, else do something else. See, 5 is greater than 3, so I print that x is greater than 3. But 3 is not greater than 3. It's equal to 3. So it comes down here and prints x is less than or equal to 3. So here's the flow chart for this. If y is equal to 6, then give a value of 10. But if y is not equal to 6, give c a value of 14. Either way, I'm going to print a because it's at the same level here. And as I said earlier, else statements can't stand alone, so this makes no sense. And the computer tells you that as well. There are times when we want to ask multiple questions. Basically, you say if some condition is true, do something, else ask another question. Now, in some languages that only have an if statement and an else, you literally combine multiple ifs. So you would say if the condition is true, do something else, and then say if the other condition is true, do something else, so forth. In Python, they've actually just turned this into a keyword called elif, but it's still short for else if, so let's see that in action. So we can see what it does. It says, if x is equal to 3, do this, print x is equal to 3. Otherwise, come down and ask the following question. So now it asks, is x equal to 4? It only asks this question if the answer to this is false. So then it says, is x equal to 4? No. So come down and ask this question. Is x equal to 5? Yes. So I'll print x equal to 5. And then it never comes down and asks this question because it stops once it finds something that's true. We can see that if I put, say, 3 in here. It's never going to ask about x equal 5. Right? What if it doesn't match any of them? Well, the flow of the code comes down here. Gets here regardless. That's going to happen no matter what happens or what the other values are. X is 4, gets here regardless. All right. This is similar to what I just showed you. Here's a flow chart that demonstrates how that works. See how if this is true, before I'd written true here, but it doesn't matter. I just did it for the sake of making it easier to read. But if this question is true, then I'm going to do what's in the body of this. And there could be multiple lines here if they were all indented at the same level. And then skip past the remaining tests and come down here. Now in this case I used an else as well, so this is sort of a fall through type value. It says this was false and this is false and this is false, so just default to this. So I can do that here. So it gets here if others are false. So this is at the level of it. This is part of the else here. So it's not the same as what I had before at this level of indentation. So here it will print both. Gets here if others are false and do this. But if I have, change that back to 4, we can see print x is 4 and then this. All right? There are many times in which we wish to write a more complex expression. And to do that, we typically use these logical operators. So in Python, we have the logical operators not, and or. And that's what they're always called, actually. In Python, they're literally spelled this way. So if you've ever programmed in C, so what I'm saying is this. So in the C programming language, then what we call a not is written with an exclamation point. A logical, that is if it's a logical not. So it says like not a, and then a logical and is written as this. Logical or is written like this, or excuse me, the two vertical bars. In Python, we literally write not, like not a, and the and or are both binary operators, so I would need to include something else, and that right there, right? So it's literally readable in Python versus something like C, where if you don't know what it means, you don't automatically just know what it means. So here I've created a truth table showing how this works. So A could represent a variable, it could represent a larger expression, but ultimately it needs to represent something that can have a truth value. And so if A is true, then not A is going to be false. It just flips the truthfulness of it. And if A is false, then not A becomes the opposite of false, which is true. For a logical and, now I have to have two things because and is binary, like I said a moment ago. So if A is true and B is true, right, true and true, then I get true. But if either one of these is false or both are false, then the entire expression reduces to false. Right? Now I can extend this to something larger, so I could say something like A and B and C and D, and in order for this entire expression to be considered true, they would all have to be true, just like on this line. But if any one of these is false, the entire expression is false. It only takes one to make the whole thing false. And finally, looking at the logical or, only one of these has to be true. And this is what we call an inclusive or. So if both are true, it's also true. And so it's here you see both are true, we get true. Just A is true, we get true. Just B is true, we get true. It's if every one of them is false, we get false. So if this expression right here consisted of false or false or false or false, then the whole thing would be false. But if any one of these is true, the whole thing is true. So when I said this was an inclusive or, I'm saying this, inclusive or, that means it also includes this. If you had an exclusive or, and that's not what this is, then having both of them true would be false. Because you'd say something like, if it's Monday or it's Tuesday, then do something. Well, it can't be Monday and Tuesday. But you might say, if it's Monday and it's raining, then it's true that you're in a bad mood. Because it's Monday and it's raining, or it's Monday and not raining, or it's raining but it's not Monday. It doesn't matter. As long as one of those is true, you're in a bad mood. Right? So that's the difference between those. So let's see how these work. And let's look at the precedence table real fast. One thing you have to be careful of, this is in Python documentation. Many times when you look at a precedence table, does this use the word precedence right here? Table. This shows you the order of how things are evaluated if you have multiple things in the same expression. Many times that you look at a precedence table, they'll go from highest precedence to lowest precedence. This table actually does the opposite. And one of the ways to test that is to look at the arithmetic operations, because you should have learned in a math class that if I have something like this, 2 plus 3 times 4, you learned in a math class that multiplication has higher precedence than addition. So what this really is 2 plus 3 times 4. They're mathematically equivalent, but since I know the precedence, I don't need the parentheses. So it becomes 2 plus 12 is 14. If you don't know the precedence, or if there was some situation where these were the same precedence, but that's not true in arithmetic, but if you didn't know that, you might look at this and say, oh, well, this over here is the equivalent of this. And then I have 5 times 4, which is 20, and that's not 14. So this is the correct answer, because multiplication and division have higher precedence than addition or subtraction. So when I'm looking at a precedence table, I usually look for this, because at least within the programming languages I've ever used, they maintain that same relationship. So you look here and say, here's addition and subtraction, which are higher on the list here than multiplication and division. So that means I'm going from lowest precedence to highest precedence. Right? Here's the where we at? The relational operators are right here. And then notice that if I'm doing a Boolean, what they call a Boolean not, what I call a logical not, and that's to differentiate between bitwise or and, right? So here's or, and not. These have lower precedence than the relational operators. And so that matters, because when you're combining these essentially are sort of glue type symbols for other expressions. So let's see what I mean by that. So I might do this. X is equal to 5. I might say if x is greater than 3, ask the follow-up question, if x is less than 99, and then say print x is greater than 3 and x is less than 99. And I get that. Equivalently, I could have done this. And let me put something here to make it clear which of these is which. So they both work. So going back to the precedence table, it sees this and evaluates it for truthfulness, sees this and evaluates it for truthfulness, and then uses the two truth values with the and statement. So this is true, so true and true is true. Let's change something else. Oops. So that's still going to be true in all cases. Now I'm using an or. But let's change this to 100 now. Let's see what happens. So the first two don't print because it's not in this range. It is greater than 3, so I did reach this point. See? But I can't. But this right here is false, so I never reach this. And so in this case, we have true and false, which is false, so it never prints. You need to know both, because as I demonstrated here, there's sometimes you may have a situation where, based upon this being true, I definitely want to do a particular thing, but then ask a follow-up question, and then only do that if that's also true. This combines the two, so there's no way of doing this part here, unless I jump through a bunch of hoops, which it would just be easier doing this. And of course here I demonstrate the or as well. So that's kind of how you combine these things. And then we could do the nots. So I might do something like this. So in this case, this would be false, and not false is true. And so we'll see that it prints 1, x is greater than 3, and x is less than 99, which isn't technically true. Now what if you get something like this? X is 100, so 3 less than or equal to x less than or equal to 500. So that worked, right? And if I change this to 1,000, it doesn't work. And we can see that. I'll put my else here. All right, so that works. So in a math class, you're used to writing things like this. The problem with this is that it will work correctly in Python, but in some other programming languages, it doesn't work correctly. And in fact, it may not even be legal. So I personally don't do this because I want to use something that's legal in any of the languages I use. Because let's think of how this works. What's really going on here? While we may think of it as x is between 3 and 500 inclusive, which means 300 and 500 are possibilities, in order for that to be the case, it has to be true that x is greater than or equal to 3 and x is less than or equal to 500. So what I'm thinking about is this. So we have 3, we have 500. Anything in here is between these two. But if I have something over here that's greater than 3 but not less than 500, and this is less than 500 but not greater than 3. So something like 248 satisfies both questions. So I prefer to ask it as 2 questions. And once again, I do that because I do a lot of programming also in the C programming language. A statement like this would be legal, but it doesn't work correctly in C. So instead, I do stuff like this. Now I'm asking both questions. So it still works. Oops, sorry. So that worked. As we saw, if I make this something bigger than 500, it doesn't work anymore. And we could change it to this minus 34 if I want. It still shouldn't work, so that's not greater than 3. Right? So here I'm using my logical AND, or as they call it, Boolean AND. So if this is true and this is true, then do this. But Python will let you write this and it still will work as far as I know. So I prefer to do one thing that works in multiple languages because since I shift between languages, if I have to remember that, oh yeah, in this language, this doesn't work anymore, or it compiles, like in C, writing this would be perfectly legal. It just doesn't work as you intended. So the program, when I'm trying to use it, it never says, oh, you shouldn't do that. It says, oh, if that's what you want to do, I'll let you do it. But it just doesn't get the right results in many cases. So I like to learn one thing that I can apply to multiple languages if possible. So that's our introduction to conditionals and Booleans, as well as logical operators. The next video will lead us into loops.